This is our lesson 5-2 notes over function tables. So our two vocabulary terms for this lesson are going to be a function rule and a function table. A function rule is just an equation that we can use to determine the inputs and the outputs of a function. Most of the time, actually all of the time, the way that you're going to see it written is as y equals mx plus b. Remember that slope-intercept form where y represents the y values, m represents the slope, x represents the x values, and b represents the y-intercept. Right? But here, okay, now we're looking more at our y and our x. So the y, okay, is going to be our output. It's always going to be on one side by itself, and sometimes it's going to be represented by different variables, but it's always going to be representative of the output. Notice the output is always on one side by itself. Okay, the input is going to be x, okay, or might be another variable, but it is going to be on the other side of the equation with maybe constants, coefficients. All right, so just keep that in mind. A function table is a table that organizes and shows the input and the output of a function, which is why it's also known as an input-output table. All right, we don't see our slope and our y-intercept, but remember that if we wanted to find m, we would just have to do these jumps and see how the y values are changing, and do the jumps and see how the x values are changing. So remember, that's how we would find our slope. The y-intercept, remember, we're looking for a 0 in the x column. But again, what we're focused more on now is our input and our output. So just keep in mind that the input is always going to be our x values, and the output is always going to be our y values. Okay, let's look at numbers 1 and 2. All right, number 1 says complete the function table for each function rule given. It's really simple. All we're going to do is take these 4 input values, plug them in for x because they are x values, and see what we get out of this function rule. All right, so I'm going to write this over here. Depending on your teacher, you may or may not have to do this. All right, notice all I did there? Okay, I kept the y, the equals, the 4, and the -1. But for x, I subbed in these 4 x values. All right, so these 4 values are written here in parentheses. And then all I have to do to figure out what y is simplify this. 4 times -2 is -8. -8 minus 1 is -9. So when the input value is -2, the output value is -9. All right, with 0, 4 times 0 is 0. 0 minus 1 is -1. 4 times 2 is 8. 8 minus 1 is 7. Okay, and then 4 times 4 is 16. 16 minus 1 is 15. All right, for this next one, we're going to do the exact same thing. We've got a new function rule. It's going to be y equals -4 times 0 minus 3. Y equals -4 times 1 minus 3. Y equals -4 times 2 minus 3. And y equals -4 times 3 minus 3. Okay, -4 times 0 is 0, and 0 minus 3 would be -3. -4 times 1 is -4. -4 minus 3 is -7. -4 times 2 is -8. -8 minus 3 is -11. And -4 times 3 is -12, and -12 minus 3 is -15. All right, so that's all you have to do. Okay, let's look at the next problems. Numbers 3 and 4 say determine appropriate input values for the following situations, then complete the function tables. All right, so number 3 says an online photo printing service charges 15 cents per photo and $3 for shipping. The total cost C for printing and shipping any number of pictures P can be represented by the function C equals 15 cents times P plus 3. All right, so we have to choose appropriate input values. I'm not going to pick negative numbers because you can't have a negative number of pictures, and I'm going to go back and tell you how I know that we're talking about pictures for our input. Okay, 1 says input P, so I come back up here. Okay, P is right here, so that makes sense that that's the input because remember the output is on one side by itself. All right, and I'm going to go back to the problem. It says the total cost C, so C represents the total cost. And then it says for printing and shipping any number of pictures P. P represents pictures. All right, so you're not going to have, so if I'm choosing values for this, I'm not going to choose negative values because you can't have a negative number of pictures. I'm also not going to choose 0 because you're not going to be paying for anything if you choose 0. So maybe I would choose, let's say, 5, 10, 15, or 20. Appropriate input values here. You could theoretically choose 1, 2, 3, and 4. Typically, that's what I will tell you to choose, or 0, 1, 2, and 3. But in this case, if you think about real life, if you are paying for shipping for something, you're likely going to buy more so that it's worth it. So this is worth the payment for shipping. So I'm going to choose, I'll do 5, 10, 15, and 20. Other numbers that would have worked, 10, 20, 30, 40. Maybe you're scrapbooking and you want 100 pictures, right? You could choose any number of pictures that you think is reasonable, right? So here, I'm going to put C equals 0.15 times 5 pictures, plus that $3 for shipping. C equals 0.15 times 10, plus 3. C equals 0.15 times 15, plus 3. And C equals 0.15 times 20, plus 3. All right, just so that we can do this quickly, we do 0.15 times 5, okay, and then plus 3. And because we're talking about money and the slope, or m, is in decimal form, I'm going to write it in decimal form. So I get 3.75. That means if I buy 5 pictures, it's going to cost $3.75. All right, for the next one, 0.15 times 10 is 150, and then 150 plus 3 is going to be 450. Could have done that one without the calculator. All right, 0.15 times 15 plus 3 is $5.25. Okay, you don't have to put the dollar symbol, though, inside of the table. We don't put units or labels inside of tables. And then for 20, 6. We're going to get $6. And instead of putting 6.00, you can just leave it as 6. Okay? There it is. All right. Let's look at number 4. It says it takes approximately 770 peanuts to produce 1 jar of peanut butter. The total number of peanuts in is represented by the function n equals 770p, where p is the number of jars of peanut butter purchased. All right, again, if you're going to the store to buy peanut butter, actually, you know what, for this one we can put 0. Okay, it's not like you buy peanut butter every single time that you go to the store. I'm definitely not going to use negative numbers, and I'm definitely not going to use fractions for my input values because you can't have a partial jar of peanut butter. It's going to be a whole number. So I'll do 0, 1, 2, and 3. 3 is kind of a lot for jars of peanut butter unless your family really likes peanut butter. All right, so n equals 770 times 0. That one's easy. N equals 770 times 1, also easy. 770 times 2, and 770 times 3. All right, the first two are real simple. 770 times 0 is 0. Okay, it takes no peanuts to make 0 jars. Okay, that's kind of weird. It takes 770 peanuts to make 1 jar. 770 times 2, I don't want to get this one wrong. That would be embarrassing. So 1,540. Okay, and then 3. 770 times 3 is 2,310. 2,310. All right, and that is it. Let's move to the back. Okay, the last two, if I can get there. Blank. Okay, it says a blank is a function in which the graph of the solutions forms a straight line. All right, so extra vocabulary, but really this is nothing new. This is going to be a linear function. If it is linear, it is a straight line. If it is non-linear, it is not a straight line. Right? So we are mostly dealing with linear functions. Linear lines sound silly, but we're mostly dealing with linear functions in 8th grade math. All right, you'll get into nonlinear functions more in algebra. All right, number 5 says create a function table for the following functions, then graph the functions. All right, here's what I'm going to do. I'm going to start simple. Let's do 0. Let me see if we can do 1, 2, and 3. I think this would work. Typically, I will tell you to choose 0, 1, 2, and 3 for your values. All right, and then I'm going to write this out to the side because I don't have a lot of room over here, or I'll do it down here. Okay, I'm going to do y equals negative 3 times 0 plus 4. Y equals negative 3 times 1 plus 4. Okay, so negative 3 times 0 plus 4 is just 4. Negative 3 times 1 is negative 3. Negative 3 plus 4 is positive 1. Negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. And then negative 3 times 3 is negative 9, plus 4 is negative 5. So let's plot these points. All right, 0, 4 is 1, so 0. I don't go left or right. Ooh, let me back up. So when we plug in our input values and we get our output values, they make ordered pairs. So this is all I have to use to make my line. So I'm going to plot those points. 0, 4 would be here. 1, 1 would be here. 2, negative 2 would be here. And then notice 3, negative 5 would take us off the graph. But as long as you have 3 points, you can easily graph your line. And that's what that one would look like. Okay, let's look at number 6. That's fairly simple. Number 6, y equals x plus 2. Let's see, I'm just going to choose the same ones. 0, 1, 2, and 3. Okay, those are usually good numbers to choose. I'm not even going to show you the work on this one. All right, I'm plugging these x values in here and then figuring out what my y values will be. So when I plug in a 0 for x, 0 plus 2 is 2. So y equals 2 when x is 0. Okay, when x is 1, 1 plus 2 is 3. So y equals 3 when x is 1. You can see the pattern here. If I plug in a 2 for x, 2 plus 2 is 4. And if I plug in a 3 for x, 3 plus 2 is 5. All right, I graphed my points. 0, 2 is here. Okay, remember when the 0 is first, that means we don't go left or right. We just go up or down, whatever this number is. 1, 3 is here. 2, 4 is here. And 1, 2, 3, 5 is here. Okay, and then I use my straight edge. That looks good. To draw my line. And that concludes the 5-2 notes.